Hi everyone, in this video we are going to learn about making user interface that is able to adapt to different resolutions. I'm going to be covering about anchors and margins, stretch settings, and pivots. Let's go through the settings I'm going to have for this tutorial. I will set width and height to 500. This is so it becomes easier for us to understand about anchors and margins. I will leave other settings as it is, though I would like to point out that whatever we do in the initial parts of this tutorial is going to have stretch mode set to disabled. We will come back to it and understand what it does later in this video. Also in this tutorial, I am going to be resizing game window a lot. Reason is that by resizing we are able to see how the game will look on devices with different aspect ratios. And when talking of aspect ratio, I will be using this term quite often in this video. Aspect ratio is simply the ratio of a resolution. For example, if you find the ratio of 1920 by 1080, it would be 16:9. So I would often use the term aspect ratio because a lot of times many different resolutions have the same aspect ratio. Let's start with anchors. Remember, when we are talking about anchors and margins, we are concerned with the control nodes only. We are going to cover more about other nodes in stretch settings section of this video. So here I have a node with a size of 150 by 150 pixels. Just for demonstration, I am going to put a node 2D in our scene. You see, when I resize window, the nodes are at their same position, and that looks all good. Let's duplicate this color rect and place it at top right corner of our screen. So now when I resize window, the right color rect node is staying at its place. Now this could be a problem. We initially designed our game for a resolution of 500 by 500, which is an aspect ratio of 1:1. But when I resize it and make the width wider, the right color rect node is not sticking to the corner of the screen. So considering we want the node to stick to the corner of the screen on whatever resolution player plays the game, we need to set its anchors properly. To view the anchors, switch to select mode. Then select the node of whose anchors you want to see. Here the 4 green handles you see at the top right are the anchors of this node. These are by default at top left corner of the screen for any node we create. You see, if I move the node, the anchors still stay at their position. Let me place these handles at the top right corner of the screen. And here we go, the node is sticking to the top right corner of the screen as we wanted. Alternatively, we can directly snap these anchors to top right corner by going to layout menu, anchors only, top right. So how does this work? Let's understand it. Let me make the color of this node transparent so it becomes easier for us to see what's going on. Now I'm going to be manipulating values in anchors tab of this control node. Here I'm going to change values of these 4 properties. So I want you to pay attention to the green handles, which are the anchors, and also for now ignore the bounds of the node which is colored in orange. You see, these values change position of these anchors. It's also changing the bounds of the node in quite a confusing way. For now though, ignore it. We will talk about them in a while. From this we can see that value of each of these properties range from 0 to 1. To better understand these properties, I have expanded the anchors to fit the screen. Let's have a look at each of them. Left property, which you see in the anchors tab, correspond to these two handles. Similarly, top, right and bottom, as per their names, correspond to two handles each. You can think of left, top, right and bottom as sides of a rectangle. So if we take a look at the value of left anchor, it is 0. As I move it towards the right, it increases towards 1. Here you see both the top left and bottom left handles are moving. I do the same thing with right side. It is 1 because we are already at the end. I move it and its value changes the same way as the left one. So left and right represents their values along the x-axis. In a similar way, top and bottom works along the y-axis. With that cleared up, let's take a look at one last thing about anchors. So here I am going to set right and bottom sides to 0.5. Ignore the nodes bound for now, just focus on the anchors. You see, right and bottom sides are exactly at middle of the screen. You can identify it by looking at the bounds of the screen, which are in blue. Let's increase width from 500 to 1000. You see, our screen width is increased, but also our anchor has maintained its position. The right side is still halfway in middle of the screen. So these values are basically percentage of the total width or height of its parent node. In the following example, as there is no parent node, it will be the screen width and height instead. For left and right sides, it's the width of the screen, and for top and bottom, it's the height. So this makes anchors useful as they adjust with different resolutions. Now let's look at margins. Margins are nothing but an offset from a given side. So if I try to change the size of the rect, you see the value of right changes. Here -30 means that the following node has an offset of -30 pixels from the right. So when position of the anchors are changed, margins are going to make sure that node's bounds maintains an offset from different sides which are defined by the anchors. So to wrap up, let's use anchors and margins together for some common task. So I have a color rect node and I want this to expand and cover the whole screen. To do this, we need to set right and bottom sides to 1. You will see that changing anchors this way is a little messy as it doesn't update margins automatically. So let's set margin to 0 and that is all we need to do. Though I'm going to undo it and perform the same thing differently. Instead, I'm going to stretch color rect node and cover it up on the whole screen. Then similarly expand anchors in the same way. In my opinion, it is much simple and intuitive compared to the previous method. You may have noticed that right and bottom margins show 500 in the inspector, and this is a small little bug with Godot at the moment, as when we move anchors manually through handles, it doesn't update the inspector right away. To fix this, switch to a new window and return back. It will refresh and update margins to their correct values in the inspector. Though you won't need to do this, as most of the time when setting up anchors, you don't even need to worry about looking at the inspector. And here we go, it works just as we wanted. Finally, I'm going to mention one last approach through which we can do this task even much more faster. Head over to the layout menu and you will see a bunch of options over here. These are common templates which we can use to quickly set up anchors. The ones you see here will set margins to 0. I'm going to choose full rect, which will cover up the whole screen by stretching all the anchors to cover up the screen and set margins to 0. And here we go. So the takeaway here is that most of the time we will be using either the templates provided in the layout or manually moving anchors with handles. So in practice, we won't really be fiddling around with anchors and margins in the inspector. Now let's do a little challenge to see different use cases of anchors and margins. Here I am using Kenny's asset for this scene. Link to these assets is in the description down below. Here I have a basic setup where we can move the player left and right, have a health bar at top left corner and a key at top right. I can press E on my keyboard to open or close the dialog box. So this scene works perfect on a resolution of 500 by 500. But if I try to run it on a screen with different resolution or aspect ratio, you see it doesn't look right. Before I show you the end result, let me walk you through the scene. I have a basic tile map and a player node. You don't need to do any changes to them. Then we have two canvas layer nodes. In the first one, I have a background that represents sky. We need to modify its anchor so that it works across different aspect ratios. Then within the UI layer, we have 3 nodes. Let us inspect dialog box first. All you need to do is set the anchors of both box and label so that they scale properly on different aspect ratios. Finally, we have the health and key nodes at the top left and right corner of the screen. So in a nutshell, we need to set anchors for all the nodes inside background and UI canvas layer. So this is how it looks right now. And this is how we want it to look like. I encourage you to try doing this yourself. I have provided project files in the description down below, or if you want, you can recreate it on your machine. Either way is fine. So if you plan to take on this challenge, you can pause the video right now and return once you are done. So let's see how to do this. It may happen that my approach might be a bit different, and it is completely fine. The important thing is that you are able to achieve the end result. And if not, it is okay, you at least tried. So we are going to do it together now. So let's look at the BG node. I am going to hide all other nodes for now so that it becomes easier for us to see what's going on. We want this node to cover up the whole screen. For this, we want to have right and bottom set to 1 while the other ones to 0. But we don't really need to make things complicated, so instead I can drag the handles manually or use the predefined layout. So let's run the game and see the result. And it works. So now let's look at health and the key node. We don't have to do any changes with the health node, as by default our anchors are set to top left already. For the key node, I need to set anchors to top right. Here I will be using the layouts given to us. I'm going to set top right from the anchors submenu, because I don't want to set margins to 0 here. Then finally, let's go to the dialog box scene. Here, for some reason, if it doesn't show up, open the animation tab and select reset. For the box node, I want it to be anchored at the bottom of the screen. So I can do so by moving the handles manually or choosing the bottom wide layout. Let's run the game and see how it looks so far. So the dialog box scales just as we want. Similarly, the key node also sticks to top right corner of the screen. Finally, let's set up the labels anchor to bottom right. Again, you can do it with handles or use one of the templates. And this is it. Our UI is now set up correctly to work with different aspect ratios. Now with anchors and margins understood, let's understand about screen stretch settings. You may have realized that when resizing the window, the size of the nodes doesn't change. That means our game won't scale on different resolution. To solve this, let's go to the stretch settings. So far we were using the default stretch mode that is set to disabled. When it's disabled, no stretching occurs. Meaning if you create a color rect or player sprite that has a dimension of 16 by 16, then it will display as 16 by 16 pixels only on your screen. So that means monitors with high resolution would display the node in 16 by 16 pixels only, which would be way too small. I am going to change this to 2D. 2D mode will scale everything to the target resolution. Additionally, with 2D selected, aspect settings now become functional. For now, let it be at ignore. It's now stretching directly to the target resolution, but it is not maintaining the aspect ratio. To fix this, let us try out other options under the aspect setting. Let's change from ignore to keep. If I try to stretch it without changing its aspect ratio, it scales as it should. But if I try to change aspect and make it wider, we get vertical black bars at left and right. Similarly, if I make the window taller, we get horizontal black bars at top and bottom. This is a useful setting for games where level design might get affected if we show more or less on different devices. So having a fixed aspect ratio solves this issue. Now let's try keep width. Let's try resizing without changing aspect. It scales as it should. Now let's change aspect by increasing width. Okay, so our width is maintained here. Let's make the window taller now. You see, here it doesn't stretch and distort, and we are able to see rest of the world when our screen is taller. This is a useful setting for games, especially the mobile games that are in portrait mode. Now let's try keep height. I resize the window, maintain its aspect, and it scales all good. Now I resize the window and make it taller, and here the height is maintained. Now if I make it wider, we are able to see rest of the world. This is a good choice for FPS games. For example, in CSGO, if you have a widescreen monitor with a wide resolution selected, you will see more horizontally. Finally, the expand option. I resize and maintain the aspect, all good. I make it wider, I see more. I make it taller, I again see more. So in all these settings, the aspect ratio was determined by the width and height we set. So what base resolution you choose really matters over here. Now let's try the viewport mode. This works similar to 2D. Now I don't exactly know the difference it offers. From the documentation, it says that it is advantageous for pixel precise games or when working with lower resolution. I have provided link to it in the description. Finally, we have the shrink property. So it basically applies scaling on top of the scaling that stretch modes already provide. So here I set it to something greater than 1. Everything is scaled even more. For lower values than 1, the opposite happens. Now again, I don't know much about its use cases, but you can check out the documentation for more information regarding this. In fact, I encourage you to look at the Godot documentation regarding handling multiple resolutions. Here they talk about stretch settings in detail. Finally, let's talk about pivot. For control nodes, by default pivot is positioned at top left corner of the node. The plus sign is the pivot here. So if I rotate this node, it does its rotation around the pivot. Similarly, if I change the scale, it scales it from the pivot of this node. So we have a property called pivot offset. We can use this to change the pivot of the control node. Here it accepts values in pixels. Now I have a pivot at the center of the node. If I rotate it or scale it, it does so from the pivot we specified. So if you look at position, it says 0, 0. Usually pivot of a node can be considered as the origin of the node. And based on that, the position of this control node should not be 0 by 0 and instead be the current position plus the pivot offset, that is 50 by 50. So I don't know why that's a case. Say for example, if I add a sprite to the scene, by default in sprites, pivot is at the center. Now at the moment its position is 0 by 0. And if I change its pivot to the top left, you see the position of this node is also changed. So that is something you need to consider when working with control nodes, as in control nodes, position is not affected by the pivot we have set. As for its use cases, we can use pivot for adding some sort of navigation arrow in our game. Here I have set the pivot to the center of the screen, and if I rotate it, it revolves around the pivot. So here I have a simple example where with the use of pivot I have created a navigation arrow which points towards the cube. And that is it for this video. So if you have any questions or feedback, then feel free to tell me in the comment section down below. So then I will see you in the next video.